Hi, this is Dan. In today's video, we are going to be expressing this given function into partial fraction. From there, we will convert this partial fraction into inverse Laplace transform. So the question says that express the equation below into partial fraction and hence determine its inverse Laplace transform. So this is Tutor Think. Please take a few seconds to subscribe to this channel before I begin. And if you need more updates from me, please click on the notification bell. So let's box on to what we have today. We have been given the function f of s equal to s squared minus 15s plus 41 out of s plus 2 s minus 3 all squared. Now, if you are really familiar with partial fractions, which I wrote as a subtopic, you can see that this is a repeated factor here. S minus 3 is a repeated factor. It simply means s minus 3 times another s minus 3. How do we convert that into partial fraction? So because I have not really discussed a video under partial fractions, I'll be taking some time to go through these few rules under partial fractions. So let's see what we have. I will not be going deeper under partial fractions, so I'll just talk about these two rules and then we start the calculation. Now, if you are not familiar with partial fractions, one of the rules says that if you have a linear factor such as s plus a, okay, this linear factor here is representing this part s plus 2. So s plus 2. If you have a linear factor s plus a as the denominator, then the partial fraction becomes a over s plus a. So the partial fraction of s plus 2 will give us a over what? S plus 2. Remember that a here is a constant to be determined. Okay, you can use any variable, but let's use a. So a is a constant to be determined. So anytime you have a function resolving into partial fraction, you look at the denominator. If it is a linear factor like this, then you take a over what? S plus 2. Now watch something. In this question, we have a linear factor s plus 2 multiplying a repeated factor s minus 3. So we need to consider this side and change it into what? Partial fractions. The rule for this part says that anytime you have a repeated factor, converting a repeated factor into partial fraction, let's assume I have s minus a or square. Converting this into partial fractions, then you have the first constant a over s minus a, then plus you have b over the same s minus a, but this time you square the other one. So if I have, let's say, s minus 3, like what we have here, all square, then in partial fraction, I'm going to have a over the same s minus 3, then plus b over the same s minus 3, then I will square this side. Now, a and b are two constants that needs to be determined. Remember that I am talking about Laplace transform in this video. I am not teaching partial fractions, but I will be needing the knowledge of partial fractions to solve this particular one. So with this knowledge, we can start the calculation. So first, we need to resolve this into what? Partial fraction. Let's resolve f of s into partial fraction. First, we will start with the linear factor. All we do is that we have a over the same linear factor s plus 2, okay, plus we have b over, remember that I use the first constant a for the first linear factor. So when I move on to this side, the constant should start from b and then move to c, okay. So here we have b over what? S minus what? 3. Then we are not done. For repeated factor, we have two constants. Then we have plus c. Remember that I have a, b, c dividing the same s minus 3, but this time I'll square here. Now, once you have been able to convert the equation into partial fraction, we find LCM on the right hand side. So what will be our LCM on the right hand side? All right, so this is our LCM. LCM here is s plus 2 the same s minus 3 all square. Okay, first we need to divide through by this. Now watch this very carefully. I'll do just one example for you. If I want to work with a over s plus 2, then I'll take the LCM, s plus 2 s minus 3 all square. I divide this result by what? S plus 2. Okay, this will cancel this. We are left with s minus 3 all square. S minus 3 all square, use it to multiply a. Okay, so this into this, they cancel. We have a multiplying s minus 3 all square, plus we have b. Now, watch very carefully. This will cancel one of these. We are left with the last s minus 3 times this. So we have s plus 2, then another s minus 3. Then this will take care of this. We are left with s plus 2. Okay, so we have plus c into s plus 2. Okay, now watch very carefully. In partial fractions, we can see that the denominator on the right hand side and the denominator on the left hand side are the same. And since they are the same, we equate the numerators. So we equate this side to what? This side. So this becomes s squared minus 15s plus 41 equal to a into s minus 3 all square plus b into s plus 2 s minus 3, then plus c into s plus 2. So from here, we need to determine the constant a, b, and c. How do we do that? There are various ways we can do this. In this one, we can try the cover up method, and from there, we can expand or pick any random number and use it to find the remaining constant. Watch, we can calculate for the constant a if we substitute s to be equal to negative 2. Why? If I pick s plus 2 equal to 0, then s is equal to negative 2. When I substitute negative 2 here, this side will become 0. Remember, I have 2 here, negative 2 here, b will become what? 0, and we can find for a. Okay, so that is what we call the cover up rule. So we are going to cover b and c. Okay, and then we work with a minus. And how do you do that? When s is equal to minus 2, or when s plus 2 equal to 0, then s equal to negative 2. You cross it. Okay, if s equal to negative 2, then we substitute negative 2 wherever we see s. Okay, so let's start from the left hand side of the equation. So we have minus 2 all square minus 15 into bracket negative 2 plus 41, giving us a into minus 2 minus 3 all square. Now note, once I substitute negative 2 here, this side becomes negative 2 plus 2, giving us 0, and the whole function becomes 0. So I don't need to work on it. Once I substitute negative 2 here, the whole function becomes 0. So this is what we have. So now when we square this side, we have 4 plus negative 15 times negative 2, we have 30 plus 41, giving us a into negative 5 all square. Okay, now when we add all this side, 4 plus 30, that is 34 plus 41, we have 75 equal to negative 5 square. We have 25 times what? A, so 25a. Now we can find a, so a equal to 75 divided by 25. So what is the value of a? This is 3. All right, so we have a to be equal to 3. Now let's go back to the equation. Now we know a. How then can we find b or c? Okay, so now look at this side. Once I substitute 3 here, a becomes what? 0. Okay, and this side, when we put the same 3 here, b becomes 0, and we can find for c. Okay, so you look at it very carefully and know which one that will be easy for you. So we can cover up a up to b, to find the value of c. So when s is equal to what? 3, or when s minus 3 equal to 0, s is equal to what? 3. Okay, so whatever way you want to put it, wherever we see s, we put what? 3. So we have 3 square starting from here minus 15 into 3 plus 41, giving us, now watch carefully, once I put 3 here, this whole side becomes 0. Once I put 3 here, this whole side becomes 0. I don't need to write it, so let's fix the 3 here. So we have equal to c into bracket 3 plus 2. All right, so this is giving us 9 minus 45 plus 41, giving us what? 5c. Okay, so negative 45 plus 41, we have minus 4 plus 9. So we have 5. 5 equal to 5c. So therefore, we have c equal to 1. Okay, divide through by 5. Now we have the value for c and we have the value for a. How then do we find b? Now watch carefully. We cannot apply cover up method here again, because when I substitute 2 here, I'll get 0. When I substitute 3 here, I'll get 0. So how do you find b? That is when you think. There are other ways. We can either expand this whole function and compare the coefficients with the left-hand side, okay? But expanding the coefficients will make this work cumbersome, okay? Because I have a repeated factor here. I need to expand it. Expand this side, group like terms before I compare the coefficients on the left-hand side then the right-hand side. So usually what I do is that let's pick any random number, okay? Pick a random number that will not make b 0. So we can pick a number like 1. Okay, when I substitute 1 here, I can find b. Or we can pick a number like, let's say, 4. So wherever we see s, we substitute what? The number 4. Don't forget that you already know the value of a and you know the value of c. So you can substitute them inside and it will be easy for you to find the value of b. So let's do that. Okay, let's substitute a random value, assuming s is equal to 4. So when s is equal to 4, wherever we see s, we substitute what? 4. So we have 4 square minus 15 into 4 plus 41 equal to, what value did we get for a? We had 3 into 4 minus 3, or square, plus b. Okay, we don't know the value of b, into 4 plus 2 into 4 minus 3, then plus c. What is c? c is 1 plus 1 into bracket 4 plus 2. Okay, do we get it now? So I've substituted the value of a and what? C. So now this will give us what? 16 minus 60 plus 41. So now let's work on this side. When we subtract 3 from 4, we have 1. 1 square will give us 1. 1 times 3, we have 3. Plus b into this plus this, we have 6. This minus this, we have 1. 1 times 6 is still 6. Okay, so we move on to this side. Plus 2 plus 4 is giving us what? 6 times 1, giving us what? 6. So 16 minus 60 plus 41, this is giving us negative 3, equal to this plus this, we have 9 plus 6b. Okay, you can cross this one here. So minus 3 minus 9 equal to 6b. So therefore, 6b is equal to negative 12. Okay, divide through by 6. So this is over 6 over 6. So this cancels. We have b is equal to minus 2. Okay, so from here, we can substitute the value of a, b, and c. So we have a to be equal to 3. So we rewrite our equation equal to 3 over s plus 2 plus, we have b to be equal to negative 2. So let me do it this way. Minus 2, I was supposed to put negative here. All divided by s minus 3. Then we have plus 1 over s minus 3 all square. So the next thing to do is to now find the inverse Laplace transform of your result. But to be able to do that, we need to factorize all these constants out. Okay, so let me rewrite the equation, then we factorize these constants out. Now, when I factorize 3 out, I'm getting 3 times 1 over s plus 2. Then, when we factorize this out, we have minus 2 times 1 over s minus 3. Then, this one, we don't need to factorize anything. We still have 1 over s minus 3 all square. So now we can find the Laplace inverse of this. So how do we do it? And we say that Laplace inverse of our result, 3 times 1 over s plus 2 minus 2 times 1 over s minus 3 plus 1 over s minus 3 all square. Now, we know that the Laplace or Laplace transform of the function e to the power at will give us the result 1 over s minus a. So when I have the Laplace transform of a certain function e to the power, let's say 2t, where a is a scalar giving us the value 2, then this result is 1 over s minus 2. So therefore, the Laplace inverse of 1 over s minus 2 is going to give you the result e to the power 2t. Now watch this very carefully. So when you look at this side, the Laplace inverse of this will give us e to the power what? 3t. Then when I take the Laplace transform of the function e to the power negative at, okay, this time the scalar is a negative value. The result will be 1 over s plus a. Remember, if this side is negative, this side becomes plus. Locate these videos in the same playlist, Engineering Mastery Laplace Transformation. I have done Laplace transform of this, Laplace transform of this. All these functions are there. You can look at those ones to equip yourself before you come here. I have arranged the video so that you understand it in order. Alright, so now when I have the Laplace transform of a function e to the power minus 2t, then its result becomes 1 over s plus 2. Then if I want to find this result, I need to take the inverse of what I have circled here. So the Laplace inverse of 1 over s plus 2 will give me the result e to the power negative 2t. Okay, so you can locate the video inverse Laplace transform, introduction to Laplace transform part 3. Okay, you will get all this. I have done all this for you to understand. Watch that video to get the basic concept before you come here. So now when you look at this one, I'll apply it here. The Laplace transform of 1 over s plus 2 will give me an exponential function minus 2t. Then let's move on to this side. For this side, I didn't talk about the principle multiplying by t when I was doing intro to Laplace transforms. Okay, there is a principle that we can use to apply when the function is squared at the denominator. Now when that happens, now I just said that when you take the Laplace inverse of the function 1 over s minus a, then the result is going to give you e to the power at. Okay, we just did it. I know you remember. It's here. It's here. So the inverse of this result will give you this. The Laplace transform of this will give you this. All right. What if we square this side? When we square this side, all you need to do is to add t here. If I want to talk about this, and I would have to need time to explain the principle multiplying by t, okay, in Laplace transform. So just do it that. So the Laplace inverse of 1 over s minus, say, let's say 2 all square is going to give us e 2t. Because of this square, you put t here. Okay, you can read about multiplying by t and the Laplace transforms, the principle multiplying by t. Okay, I'm not sure I spoke about it in this channel. I'll try my best to see if I can do that. All right, so let's now write the result for our answer. When we take the inverse of 1 over s plus 2, the result is giving us e to the power what? Minus 2t. If this side is plus, we have minus 2t. Then we have minus 2. This side you multiply by what? The 3. Then when we take the inverse of 1 over s minus 3, we have e to the power 3t. We learned that if this side is negative, this becomes positive. Then when we take the inverse of 1 over s minus 3, we still have e to the power 3t. Because of this square, we put t here. So the Laplace inverse of the function f of s, I don't have space to write f of s, okay? F of s is this. So when you take the inverse of this function, when you finish solving, the result is what? 3e minus 2t minus 2e3t plus te to the power 3t. And this is your final answer. So thank you very much for joining me here. This is Daniel, and I will see you in the next one.